Okay, this is going to be a quick little introductory video on setting circles for an equatorial mount. I have a much more in-depth video. It's actually in 3 parts, I believe, on setting circles, and the 3 of them altogether last close to 45 minutes. So this one here will be kind of quick just to show you what's going on. This particular mount is it's an EQ3 type. This was off of an Explore Scientific that I just did the review of not long ago, the AR-102 refracting telescope. So this one here, this is your declination circles, or circle, I should say. And then over here is right ascension. So this one, the declination is north and south numbers, and right ascension is east and west. The declination is in degrees, and the right ascension is based on a 24-hour clock because of the rotation of the Earth being 24 hours. So it's in hours and minutes, and you can even get down to seconds, but this setting circle's not large enough to get very accurate, okay? It just goes down to minutes, and I think it's even like 5-minute increments or something, and you just kind of estimate it. What it does is these here are good enough to get you in the ballpark if you're going to one area of the sky. You still need to learn some about star hopping and finding your way around the sky. I'll show you a little more on each one. So here's a closer view of your declination setting circle. And as you can see, it's just numbered 0 to 1 and so forth. So what those are actually 10 degrees apart. So this one here, since it's such a small circle, it's not all that accurate. But 0 degrees would be a specific area of declination for an object. And then you could go up to, like, from 0 to 3 to 6 to, say, 10. And then, say, 13 and 16 and 20 and so on. And on one side you have positive degrees, which means it's above the equator, so it's on the northern half of the sky. And the other side would be 0, or negative, excuse me. The other side would be negative, meaning closer to the southern horizon. And a lot of that just depends on where you live as to how high they are in the sky. Okay, so now we have a close-up view of your right ascension setting circle. So you can see you go 0, 1, 2, 3, on around. As you get to this side, you go up to 23 and back 0, which would be 24, which they don't list one as 24, but just below it would be 23 hours and say 59 minutes. And these are in increments of, I believe this is 10 minutes. So you 23 hours, 23, 10, 20, 30, 40, 50, and then on back to 0. And but notice here, you have 2 sets of numbers here. It just depends on which hemisphere you're in. Since I'm in the northern hemisphere, I'm using this lower scale of the 23. If you're in the southern hemisphere, then it would be the ones up there on top, which just it just runs in the opposite direction. Okay, now a lot of people would wonder if you can use setting circles as a form of go-to, like, the newer telescope mounts are often computerized and have a go-to function. Well, this is a go-to function, but it's very old technology. And either way, whether you have the new technology or the old, you need to learn the sky at least to a certain extent so that you can find your initial object. This one here, you need to be able to do it more, much more. I say this here is not near as accurate as a go-to type with a computerized go-to. It really can help you find objects in the sky, and a lot of use out of these. I think they work the best if you're in a place where it's good and dark, so you can see lots of stars, and it kind of helps you star hop from one bright star to another and then find an object. So the first thing you would need to do, of course, after you get your polar aligned reasonably well, like I showed in my other video, particular amount the review, to find a star, you're certain of what star it is. It might be Vega or what have you, something where you're certain by looking at a star chart which one it is. You have to get the coordinates for that star. Apps on cell phones and stuff that show you the sky, and just depending on what one it is, it might tell you the right ascension, which would just be listed as RA, and the declination, which would probably be listed as dec. And then you could estimate it on here. Here, spin freely. The one here on the east-west RA, this one's a lot tighter, and that's just because of this specific mount. There's no set screw to loosen and tighten the actual wheel. Larger mounts have a set screw where you can tighten and lock it in position. But with this one here, it's just supposed to slide by friction. I think it's just designed, the tolerances. RA is just really tight. I can move it, but it was a challenge to move. Tight that wants to change the position of the telescope. May not be that way with one if you buy it. It just depends on each model, I think, or each specific scope. You found a star and you know it's at declination. On this particular setup here, 3, and of course in this case it's plus 30, be minus 30, and ended up with the indicator, which I opened in this indicator with a Sharpie marker because it's the same color of white, so it was a little harder to see. So on both declination and RA. There, while you have the object centered in your eyepiece, and then do the same thing over here on right ascension, which in this case I'm set for about 21 hours, maybe 25 minutes. It's kind of in between. As you can see, when you're trying to get there, it's guesswork. It's got times all the way down to fractions of a second, and you don't need to worry about that on here. You're just estimating in minutes. After you get the hours, you can get to 21 hours and then estimate. And that gets you the ballpark. A bright star, and you know it's there. And you want to go to another bright star, but you're not sure which one it is. Coordinates. What you have to do is set your east-west here. And over to it. Let's say you're going from this 2125 to, I'll say 17 hours. Here to the 17 indicator and lock it back in. Do the same thing with your declination. Okay, so now you've already adjusted your right ascent new star. You want to go to another star, and let's say it's at 60 degrees plus. We'll say positive 60. We're at positive 60. Telescope. Circle moves along with it as you move the telescope. Get it up to 60. In your eyepiece, it could be, depends on what magnification you're using. If you're using real low power, but more or less you want to look in your telescope and a bright star in it, and then you just center it up in your crosshairs. Eyepiece, and then as you get closer, let's say find a deep sky object that's this bright star. Let's say, okay, you've got to the next star, and you know there's in to the north, so let's say it's 65. 62, lines are fine, about 63, I guess. Somewhere right in the middle. And then you're to kind of do a little bit of adjusting. So now say pretty close to this object you're trying to find that you've never seen and you can't see with naked eye, and you got to try to find it in the telescope. So now you're kind of trying to search a little. In your right ascension and declination, it's best to have a plan. Let's say, for example, you see a center. You can use your ascension and go clockwise slowly and drift over a while and then say, okay, I didn't see it, so let's go back the opposite direction now. And you see that bright star that you just saw a minute ago, let it go back by. Don't go back again and try to center it. Let's say that goes in the of your view, move it up to the top of the view, and then go back and forth, and you just search for it. You can possibly see in your specific telescope, if it's good enough for dark sky and all that, maybe you'll find it. So hopefully that helps, and I'll leave information on my other videos, because that's a lot more in depth.